With the visualization webinar today, I want to cover the following areas. So I'm going to start with kind of a brief history of visualizations in LabKey, kind of show what tools and features were integrated along the way to get us to where we are with the most recent LabKey release. I want to talk about how to use some of the built-in visualizations, where you can find the user interfaces for creating them, sharing them, saving them. I want to focus a little bit on kind of the more recent changes or additions within the last year, as we've kind of focused on building out those built-in visualizations to kind of highlight some of those items. Give a list of kind of some potential future areas of focus that we have heard from different users or have thought of along the way ourselves, to kind of show what that might look like. And then end with some demos and cover some user scenarios that go beyond kind of the built-in visualizations to show some interesting use cases. So for the history of visualizations in LabKey, I took and I triaged some of the release notes from over the years to see how we got to the current state of visualizations in LabKey. From what I could see, it all kind of started in 2006 with the integration of R. So this kind of was the starting point of our reporting infrastructure for creating and saving reports within the LabKey server. Then the chart view designer was added with version 8.1. It has since been deprecated, but it was kind of the first grid-based chart creation tool built into the LabKey server for creating basic scatter plots and line plots that made use of a J-free chart library to do the plotting itself. The study-specific time chart was added with version 11.1. This was a way to view data points over time for LabKey studies by their visits and dates for a participant or a group of participants within a study. The JavaScript Visualization API, which makes use of the D3 JavaScript library for the rendering, was added with version 12.1, and I'm going to show some demos of this along the way and talk about it more throughout. But this is kind of a set of a package of components and helpers that we use for various built-in charting tools, but we also make available for other module developers to use for more custom visualizations. Once that visualization API was in place in 12.2, we also created a kind of starting point of our charting wizard for creating box and scatter plots using this wizard. With version 13.3, the data views browser web part was added to allow users to see saved reports and charts, to categorize them, to organize them, and share them with other users. With version 14.3 and 15.1, we started extending this JavaScript visualization API to include more components for creating things like bar charts and pie charts. These were added for more specific client scenarios, but were included in this visualization API, and with the hopes that we would later build them into our charting wizard, which we did during the 16.3 release. At the same time, in 16.3, we did kind of an overhaul of that user interface and user experience of the charting wizard, which I'm going to do a demo of and talk about more later. With version 16.3 is also when we added column charts to allow for exploration of things on a per column level while looking at a data grid in LabKey. This allows for you to look at a visualization of data without having to kind of leave the screen or go to the charting wizard, kind of with a single click visualization. And then finally, with the latest 17.1 release, we incorporated the time chart wizard that I talked about with the other charting wizard tools, so that there was kind of a single user interface for using these chart types for data grids in LabKey. And with this, we also added some more specific chart options for the existing chart types, for example, grouped bar charts or binning for scatter plots. This slide just kind of shows a little more detailed overview of what I just mentioned. The bold items are the ones I covered, and I'm not going to go through the rest, but I did just want to show this to indicate that, along the way we were, also making more incremental changes. We've been kind of focused on visualization throughout, to adding little pieces as we go. And as you'll see on the right-hand side with the more recent releases, a lot of those additions have been made or incorporated into that JavaScript visualization API. That allows us to both internally make use of that API for our built-in charting tools, but again, like I said, expose that for module developers to use to create more custom visualizations for their user scenarios. So I did want to just spend a little time in the next section to quickly show a few slides of the various UI or jumping off points for the LabKey server for creating these built-in visualizations, and then kind of classify them as far as which ones are kind of the click and built-in easy to create visualizations, which ones are more developer oriented, and then some of the external client data access. So the main starting point for creating one of these built-in visualizations from the LabKey data grid is from the button bar at the top of the data grid. We have two primary buttons that control access for these charting features. The first one being the charts menu. So we've consolidated this menu down to a single create chart menu item that is the jumping off point to get to that charting wizard, which I'll show. And then once you're in that wizard, you can then select between the various chart types listed here. Next to that charts menu item and for data grids is the reports menu item. This is where you'll find the create R report and JavaScript report options. These are the more developer-oriented report types that allow for a greater customization and flexibility, but it would involve writing your own code or using the language-specific packages for those two options. Then with that data views web part that I mentioned, there are create menu items for all the things listed above, in addition to some more report types like attachment reports and link reports that allow for more static content that can be attached to a folder within LabKey or attached to a data grid. This might be something like a PDF report or a PNG to associate in that way with a data grid in LabKey. Kind of after these built-in data grid visualizations, we also have some built-in assay visualizations that take on different flavors depending on the various different assay types in the LabKey server. These visualizations use various different tools or charting packages to generate either static images in some cases or more interactive visualizations that are specific to the given assay and to that assay's data. For example, the proteomics assay uses visualizations on the peptide details page to view analyzed results from the mass spectrometry data. The flow assay, flow cytometry, has a page where it embeds thumbnail images into the data grids itself to visually represent the analyzed data next to the numerical result sets. The neutralizing antibody assay in the upper right has a run details page that shows data points from the uploaded data for a given standard, along with a polynomial curve fit for those data points. On the bottom left, there's the Luminex assay, which has a Levy-Jennings report for tracking quality controls over time for a selected standard or titration, and then allows for filtering the data down by analyte, isotype, and conjugate. And then the Panorama data types have various QC plot types very similar to the Luminex tool that are used for tracking quality control over time as well. But in this case, the different metrics of data are defined by queries over the targeted MS assay results data. Kind of after those built-in visualizations, like I mentioned, we have the JavaScript visualization API. This is the set of building blocks for many of the visualizations in the server. Again, it uses the D3 charting library for the rendering, and it can be used to create more custom visualizations by defining different layers or geomes and shapes that can be overlaid on top of each other, such as data points, lines, error bars. And then there's APIs for these plots that provide programmatic hooks as well for adding plot interactions. For example, you can, as a developer, define a function that is called in JavaScript when a data point is clicked to either navigate the page or show more details about the point that has been clicked on. In some places, we saw that there was a need to reuse configurations from these building blocks in several different places within the product. So in those cases, we have created plot helpers that we've called them to make it easier to define a configuration for a specific chart type. For example, on that last page, those Levy-Jennings reports for both the Luminex and the Panorama data both make use of this trending line plot helper to build up the configuration for defining the parts of that visualization in a more simplified way. And then beyond that, beyond the kind of built-in charting tools and APIs, there can sometimes still be a need to use an external tool for data analysis or charting. And for those cases, we've built several client APIs to get the same set of data that you can look at from a LabKey data grid within the UI, get that exported to the various different supported programming languages such as Java, Perl, Python, or R. These client APIs have data access or allow data access that applies the same user context in the same way that the LabKey server user interface does, that would allow users to only see data that they have access to for a given container or a set of containers. One quick way to get a starting point for one of these client APIs is from the data grid. There is an export script menu item. This allows you to get a kind of basic shell script that gets you started with, how would I access the data for the given data grid I'm looking at, how would I get that to the programming language and see the kind of syntax that I need for that given programming language. For example, to pull through things like column filters that I might have applied to the data grid itself. And then finally, at the bottom, there are options within LabKey data grids to export the data to Excel or TSV for other reporting tools that don't match up with some of these programming languages. So next I want to focus on those changes that have been made most recently over the last few releases, starting from version 16.2 to the current 17.1 release. We've put in a lot of effort over that time to kind of make creating visualizations and using these built-in tools hopefully easier and quicker to find, and make it easier for you to get to kind of what you're looking for or find the built-in tools themselves. So first, I want to talk about the addition of column visualizations. This was added with version 16.2 of LabKey. This was added as a more exploratory way of visually seeing the data for a column in a grid without having to write code or leave the data grid page itself. You simply click on a column header for the column of interest, click on the menu item that represents the plot type you want, and with that can add a box plot, bar plot, or pie chart representing the data from that particular column in that grid. With these visualizations, these column visualizations, the plots do respect the saved or user-added filters for the grid, and then they update to refresh as new filters are added or changes are made to the grid. These visualizations can then be saved with a custom or default view. For example, you could take a study demographics data set and create kind of a dashboard type of a page to see the contents of that demographics data set using these mini visualizations. The saved views can then be shared with other users that would then see the same set of column visualizations that have been added to a given view. Another major visualization related change that we made in version 16.3 was, like I said, for the charting wizard. We did a revamp of this user interface for the charting wizard to make it easier to use and easier to select the charting options you want without having to jump between so many different dialogues or pages to make these selections. With this revamp of the charting wizard UI, we also added some new chart types to the tool. These were chart types that we had previously defined in the Java Visualization API along the way, but we had not exposed in the charting wizard itself. So prior to 16.3, you could use the charting wizard to create box plots and scatter plots, and then now with 16.3, we added bar charts and pie charts, and then 17.1 rolled the time chart wizard in with the single charting wizard interface. And then related to that last slide on column visualizations, we kind of tied those two together so that when you're looking at a column visualization for a data grid, you can click on it and go to the more full-featured charting wizard where it pulls along those selections of the column or the variable that you want it to plot along with the chart type. In LabKey Server version 17.1, we also did some revamping and updating of the column summary statistics for a data grid. These summary statistics are aggregate functions that can be added for display at the footer of a column in the LabKey data grid. And in previous LabKey versions, these statistics could only be added to the grid using the custom views UI dialog, but now they can more simply be added by clicking, again, the column header menu item for a grid, selecting the summary statistics option and seeing a dialog like the one I have screenshotted here in the slides, where it lists all of the supported aggregate functions or statistics for a given column based on that column's data type. So this dialog displays the list of statistics, but then also the actual calculated value based on the column that you're looking at, on the grid you're looking at. And then as with the column visualizations from the last slides, these selected summary statistics can be saved with a custom view so that they can be shared between users or appear on the view as you return to it at a later date. And then finally, some additional kind of more incremental changes made to version 17.1 related to visualizations. For the Panorama QC folder type, we added some new plot types. Previously, it only showed options for a Levy-Jennings plot, but then we with the 17.1 release added a moving range plot and both mean and variable cumulative sum plot types. And then in the upper right for scatter plots, we added options around binning the data for plots that might have a large number of data points. We were seeing that there were some cases where certain browsers would run into performance problems when you have a very, very large number of data points, and we didn't want to kind of lose that representation of the full data set. So this binning or density plot view allows you to kind of keep that full data set around while being able to see kind of the distribution of the data points. And then, like I had mentioned in the bottom right, the time chart wizard with 17.1 was merged together with the more general charting wizard tool to make a single entry point for building these built-in chart types off of a data grid and make it easier to kind of toggle between them as you're creating your report. And then finally, we added support for grouped bar charts to allow for a selection of a second x-axis grouping variable to be added to the plot for the bar chart type. So I want to just step over to my local server for a little bit and do a demo of kind of some of those more recent additions to show kind of where in the user interface the entry points are and what they look like. So for that, I have loaded here on my local server the LabKey.org demo study, which is a fictional study, a made-up sample data set, but built to represent an HIV progression study for multiple cohorts and treatment groups. I'm going to start by clicking on the Clinical and Assay Data tab. So this is the default location of the Data Views web part here. So this, in this case, is listing out the various different data sets and views that I have for my particular study. It also is where the saved reports, charts, so in this case, scatter plots, and time charts at the bottom here, along with any R reports that I have saved for my particular study. I'm going to go ahead and click on the physical exam data set to show the column visualizations that I've talked about. So in this case, I'm looking at a grid of data, and I can click on this pulse column, this numeric column here. When I click on the column menu, it shows me options, and one of them being the box and whisker plot option. So clicking that will, without navigating, without leaving the screen, add a simple visualization to the header of my visualization, or I'm sorry, my data grid here, to show the distribution of values from that column within my data grid. For more categorical or non-numeric data type columns, we offer pie chart visualizations and bar charts, so I can add a couple of those here to represent the distribution of those columns. And like I mentioned in previous slides, the filtering and things on this data grid will apply and to these visualizations. So for example, if I take this antiretroviral regimen type column and I add a filter to remove those blank values, I can do that, which will refresh the page, update my data grid, and also update the column visualizations. So even though I haven't saved this view at this point, the visualizations that I've added have kind of stuck around, so they're saved in session while I'm working on the view, and then I could save that view at a later date to make them stick around beyond this session. For the charting wizard tool, I mentioned up here at the top of the grid, there's the reports button and the charts button. So I could go ahead and click this create chart button to go to the charting wizard. But I'm actually going to, in this case, click on one of the column visualizations to show an example of kind of a rendered chart right away from the charting wizard. So this has pulled through that selected column, the antiretroviral treatment regimen type column, and as well as the chart type of a bar chart here for the charting wizard. If I click on the view data button in the upper left, you'll see that the filter I had applied to that grid is also pulled through to show non-blank values. I can clear that filter here and go back to my chart to have it refresh to update with the full data set of the physical exam data in this case. As I had mentioned, we did kind of a revamp of the user interface here for the charting wizard. It used to be the case that when you're in kind of edit mode for a visualization for a chart, there was a handful of buttons across the top here with different options for customizing the different axes and layout options for a chart type. You'll now see that in the upper right, we've condensed that into 2 buttons for the chart type and then the chart layout options that are specific to that chart type. So if I click on the chart type, you'll see the left-hand side here represents the different chart types that I can toggle between for this particular data set. I'm going to go through them real quickly to show kind of examples of each and about the customizations for each. So we've seen a basic bar chart here with a single x-axis category selected. I can go ahead and add a second variable for creating a grouped bar chart that is split that first category by, in this case, the pregnancy variable from this data set. And then on the y-axis, I can also add a numeric variable and kind of do additional aggregate methods of that variable across the different categories, or in this case, multiple categories. So I'm going to leave it selected as the sum of my pulse variable. So if I apply that, we'll get a grouped bar chart. Again, this data set is heavily dictated by the blank values in my example data. So I'm going to go ahead and filter that out again quickly. And now when I come back to the chart, it updates to show kind of that grouped bar chart of the x-axis variables I've selected, and then on the y-axis, the sum of the numeric pulse variable. For the box plot example, again, the box plot allows selection of the x-axis as a categorical variable, the y-axis as a numeric variable, and then in this case, it allows for a third variable to be added, or a fourth variable for the color and shape. So this would apply to the data points for the box plot for outlier data points by default. I'm going to use that pregnancy variable again. I'm going to put it in the color attribute, and when I apply that, we'll see a basic box plot. In this case, I do not have any outlier data points for the box plots that you see. However, using the chart layout menu item, I can see the various different options we have available to customize my box plot. And so one of those being the ability to show all data points. I'm going to go ahead and jitter them as well. And let's actually change the opacity down so that we can better represent overlapping data points. I'm going to leave the rest of these options the same to their defaults, but I did want to point out that in addition to kind of general options for the selected chart type itself, there are axis related or other kind of categories of options that you can customize, such as the label on the x-axis for a a box plot, and then on the y-axis you could use a log scale or change the range manually as well. So if I apply this, we'll see that third variable come into play about coloring the data points for the box plot based on that pregnancy variable again. For pie chart, there's a single variable selection option for the categories, so the distribution of showing the pie slices based on the distinct values in that variable. I'm going to leave the selection to default just to show a quick example of a pie chart here. And then again, pie chart has its own set of customizable features for selecting, for example, the color palette to use for the pie wedges. I can also change the inner radius of the chart to show more of a donut plot, along with a few other options that I'm going to leave to their defaults for right now. The scatter plot is often used to compare two numeric values. So in this case, I have 2 blood pressure related variables from my physical exam data set. I'm going to add those on the X and Y axis to compare them. And again, I can use additional variables for coloring the data points or shape, using different shapes of the data points. So in this case, I'm going to bring in that pregnancy variable again for different shapes of my data points. And then for the chart layout options of a scatter plot, I did want to point out, as I had mentioned, that density plot option. So my specific demo study here does not have enough data points to reach this threshold of 10,000 data points, but I can turn on the density plot to give you an idea of what it looks like. So if I apply that, you'll see, the idea would be if we had a lot of data points, we don't want to kind of slow down the interactions of our browser by rendering that many objects, so we kind of render this more heat map view of the data itself to still see the relationship of the distribution of the data points. And then finally, for the time chart type, this is again a study-specific chart type added to the charting wizard. The x-axis is defined to show series data over time, so either for individual participants or for participant cohorts and groups within a study. My demo study here is a date-based study, so that option is selected by default. If I had a visit-based study, I could also switch between date-based and visit-based. In this case, I'm going to leave the defaults to calculate the number of days for each of my participant visits as calculated against the start date from a demographics data set that I have. The time chart does allow multiple variable selection on the y-axis, so I can drag in multiple numeric columns. In this case, I'll put the pulse variable on the left-hand side of the y-axis, and I'll take the temperature variable and I'll move it over to the right-hand side so we can see what it looks like with 2 different ranges applied to the chart. So if I apply that, by default we get a single chart with, on the left-hand side, per participant selected. So by default, we simply pick the first 5 participants in a study, but I can change that selection on the left-hand side. I could also use the chart layout options for time chart to show aggregate data across cohorts. So for all the participants in a given cohort, show me that series of data. In this case, that filter we had applied on the non-blank values has restricted our initial set to just a single participant. So I'll actually remove that filter, and you'll see we now have 10 series of data in our plot here representing the 5 different selected participants across the 2 different selected measures. As you'll see in a single chart, this is kind of a hard to see where the relationships are, but we can use the chart layout options to, in the time chart case, show 1 chart per participant. So this would break up the charts by participant and show that pulse versus temperature series data over time. I'm also going to change the x-axis to, instead of calculating the range automatically across all of the charts, so across all of the participants, to show that range automatically calculated within a single chart. So when I apply that, you'll see we now can scroll through the individual participant plots showing the pulse variable on the left-hand side and the temperature variable on the right-hand side as we scroll through. For any of these chart types from the charting wizard, when you have kind of in edit mode as with the proper permissions, you can save that chart, give it a report name, a description, decide whether you want to share that with other users or that have access to this LabKey container. This kind of saves the configuration. It doesn't kind of snapshot the data. So what it does is it saves the selected chart type, the measures or columns that I'm using, along with any of the chart layout configuration parameters, and then when you would come back to this report, it would then pull the most recent data and display it. So you're saving that configuration of the report, not the actual kind of snapshotted view itself. To snapshot a view, there are the export options to export to PNG or PDF. Another use case that we have is, as a developer, I can select this export as script option. So I'm logged in right now as a user that has developer permissions on this server. So I could take this script, and again, it uses that JavaScript visualization API to build up the building blocks of the chart we were just looking at. But I could take that script and then apply it in other places of the product if I wanted to bring it to a custom view within a module that I was developing, or put it on a different tab. For example, I've created this reportings tab on this study that shows a page that includes multiple visualizations together to kind of tell a story or to show kind of a cross-section of the study data that I have. So in this case, I've included multiple web parts for some of the visualizations we've looked at. For example, the demographics data grid here with the column visualizations saved to the default view. If I scroll down, we'll see there is a reports web part added for one of the saved scatter plots showing the viral load versus CD4 positive variables from the lab results dataset from this study. And then I also have saved a time chart for per participant group time chart, so it shows series data for aggregate data across a participant group, in this case the lymphocytes variable from the lab results dataset. So to jump back to my slide deck, we had talked about, and it's kind of some future areas of visualizations that we haven't done or haven't really prioritized, but just kind of keep a list of things we've heard from users or things we've encountered along the way that might be interesting to add. We've heard interest in more integration with other charting packages, so Spotfire or Shiny, for example, to be able to more tightly couple the data within a LabKey server to some of those charting packages. We've also heard interest in adding more supported chart types like line plots or adding linear regression lines for scatter plots. I talked about some of the column summary statistics, but there's other basic statistics that I've thought about adding for things that you can do right now using an R report as a developer, but just kind of pulling them out and making them a little easier to kind of see or integrate with the data in the LabKey server. Pivot charts, also an interesting topic, or adding additional grouping mechanisms directly into the plot, into the charting wizard, for example, to see pie charts for each cohort or each group that I've defined in that container. And then more kind of charting interactions. So some of the things that we've added to the visualization API for brushing, for example, to use that in like the charting wizard for filtering or zooming would be an interesting addition to add in the future. I did want to just kind of end this presentation with kind of showing a few user scenarios to give an idea of some custom visualizations that either LabKey has developed or in some cases users have developed in their own modules. And I tried to pick these examples to show kind of some different scenarios as far as the sources of data or the programming language used, so we can kind of compare and contrast them. So I'm going to jump back over to my running server where I have kind of taken some screenshots of these 4 different user scenarios I wanted to show. The first one is a timeline report from the Genomics England group, and I'm going to scroll to the visualization while I talk about it here. So this is a report that allows the cancer clinicians for their server to a visual representation of a patient's set of events. So they can easily see the kind of relationship, the various position of the various different events for that participant, and get an overview of the types of events in that person's history. And also to filter the corresponding data grid for this chart to see more details about the individual data points themselves. So to scroll up, for each of these examples, I've listed out kind of some of the technologies used. So interestingly, for this use case, the data is coming from schema tables, so a set of tables that is defined by the module itself. So it creates these tables in the LabKey server database. In this case, the Genomics England group has defined this set of cancer data tables that store their data. And then in the JavaScript visualization API from LabKey is being used to actually render this report. So it's pulling the data from those tables and using one of those plot helpers that I mentioned in the visualization API for creating this trend line or a timeline report. And with it, the user can then interact with the report to click on a row, and at the bottom there's a grid that shows kind of more details about the selected row or event, and in the case of clicking on a data point, it shows more details about that specific data point or event for that participant. The second user scenario I wanted to show comes from the Novo Nordisk group. So these are a set of R reports that they've created for their studies. I'll scroll down to the visualization while I talk about it again. So this group makes heavy use of these R reports to visualize study dataset data to track trends across multiple combined studies. These studies all belong to the same data space, and that allows them to track the performance of their diabetic animal model. Having these study datasets defined as part of a data space allows for the visualizations to cross studies or to include data from multiple studies in a single report. And then from this combined data grid view, users can use the standard LabKey grid filtering features to drill down on a specific set of studies or subjects or treatment groups. And then since the R reports themselves respect the given set of filters, they can generate the report on that subset of the data. And they don't need to then have duplicate copies of the same code for a predefined set of filter options. They can instead have the reports used to explore the data set in various different slices of the data. So in this case, they are using the study module in LabKey to define, like I said, a data space project. So that with that, they define the dataset definitions kind of at the project level one time, and then each of their subfolder studies loads its own data and has its own permissions for the users. And then since the definition is defined in a single place, the reports can query easily across those studies and get the same set of variables for these different reports. For example, scrolling through them here, they can have line plots and scatter plots showing, in this case, the performance of a particular positive control compound across the different studies. So each colored line here represents a different study in their data space. They can kind of combine that cross-study reporting to, in this case, use a Kaplan-Meier survival analysis in R to generate a mean trend line with expected ranges, and then use the individual colored data points to represent the different studies and the different cohorts within that study and where they fall in relationship to that calculated trend line. They have an R report that does more of a stepwise Kaplan-Meier survival plot, comparing the different years of data, so the data by year across studies, broken down in some cases by quarter for a given year. And then finally at the bottom, kind of pulling these together for a single study, they have R reports that bring in that median trend, that mean trend line across all the studies, but show it in relationship to an individual study's cohorts, so where the data for that cohort falls in line or unaligned with the expected ranges. The third example here is from the IDRI group. They are using the HPLC assay. They've created this quality control tool which allows users to perform quality control analysis aided by their data visualizations. The chromatogram visualization presented for each sample provides a direct sample-to-sample comparison. It also allows for region selection for setting bounds and for form-bound visualization selection to define the standards. In addition to the interactive chromatograms in the middle of the visualization, there's visualization on the upper right, which shows the standard curve regression line by plotting the concentration versus response for that standard. To talk about the data source, this one is actually pulling data from tabular data files. So they are using the HPLC assay to upload their assay results, and then attached to those assay results are, I believe, TXT files or tab-delimited files for the XY pairs that represent the chromatogram. So this is actually a scatter plot being rendered, even though it looks like a line plot. They just have a lot of data points to make it from this scatter plot. But this is rendered using the JavaScript visualization API, again, provided by LabKey, to render the individual chromatograms here, as well as the upper right-hand smaller visualization of the concentration response curve. The user then interacts with this visualization to click on a standard name here in the grid to highlight an individual chromatogram. They can also then use the bound input properties here at the top to specify the left and right, top and bottom bounds of their plot so that they can investigate different peaks for that chromatogram and zoom kind of in and out as they look at things. And then finally, the fourth example I wanted to show is from the Panorama group. They're making use of a third-party tool called Clustergrammer to provide heat maps for, in this case, targeted MS data expression matrices. So LabKey has leveraged the APIs from this clustergrammer tool to take the data that is stored in the LabKey server and send it to that free web service to generate these heat map visualizations so that a user can look for upregulated or downregulated proteins by their constituent peptides in targeted mass spec data. Again, this tool is kind of third party. It's integrated with LabKey in the sense that a user can select runs from the targeted MS runs grid, click the clustergrammer heat map button, which then packages up that data, sends it to their web service, and which generates the visualization and returns a link. That link is then stored in the LabKey server as a link report so that users can come back to it at a later date, click on the link, and then go over to the clustergrammer tool to interact with that visualization. In this case, the heat map allows for sorting, filtering, zooming, various different interactions provided by that tool itself. So that is all I had for kind of the demos and user scenarios I wanted to cover. So I wanted to thank you for joining me for this visualization webinar.